Hello everyone, my name is Dairum Kamuri. Today I'm excited to walk you through my submission for the ArangoDB hackathon. I participated because I'm passionate about using modern data technologies to solve real-world business problems. And private equity is a field where timely insights can make all the difference. I'm a machine learning engineer based in Harare, Zimbabwe, and I've seen firsthand how the right insights can transform business decisions. So in this, we are going to go through the Shark Tank dataset, uh, the investor names, the entrepreneurs' names, the deal valuations, the asking price, as well as how much a particular investor or shark invested in the business. So to start, we are going to prepare our dataset. We load it through. So it's here in our Kaggle platform, which is a very intuitive platform to use for data science projects. Here's a sample of the data. As you can see, it's got many now values denoting that investments when made or a startup did not receive any attention. So we prepared the dataset by standardizing our column names. We see the dataset summaries, and then we list the columns where we replace the now values with zero, especially the numeric amounts to prepare them for our graph database. Here's a list of the columns. We drop some unnecessary columns for our use case. And also we replace the now values accordingly. So to load our graph data, we use the Python library NetworkX. So we would want to build a graph-like database where we've got our startups, our investors, and then we connect them via the investments that were made. So we create unique nodes for each shark and company and then define edges based on the investment. We add investor edges for each investor column. And here's an initial visualization of the graph. So it's a circular layout representing entities in the network for the initial visualization. So this shows that this network structure is not inherently hierarchical or spatial. And the node clustering and centrality, especially the central black blob, represents a cluster of nodes with many connections, indicating that investors have made many investments in many startups, and some investors have made investments in the same startup. So to persist in the graph ArangoDB, we create collections, a collection of startups, a collection of investors, and a collection and an edge collection of investments. We install the PyArango helper library. We then input our connection details, clean our node keys to remove invalid characters, and then ensure that our collection exists. Ensure that investments is an edge collection of type 3, which was a problem for us when we were trying to create the investor relations between the startups. It was always defaulting to type 2, and we couldn't get the list of startups by investor. But we eventually got through that problem. We persist our nodes, and then we persist our startups and investors. So we did a lot of print statements to debug our code, but we made sure that everything persisted correctly, our startups, our investors, and then our investments. Here are some simple query results from correct persistence. So we've got a query for startups, returning our sample of our startups, a query to check if what type Mark Cuban is an investor, then a query of sample of investors, and then a query of samples of investments themselves. So to build our agentic app, we did some simple queries in ArangoDB. So we repeat that connection string where we supply our URL, our username, and our password. And then we create functions for the complex query, the hybrid query, as well as extracting the investor name. And then we execute these queries. So we did some example queries where we showed find out direct deals of Kevin O'Reilly, find both direct deals and community insights for Mark Cuban. What are the top 5 startups by valuation? Who is the most influential shark, and so forth. So here are some simple results from those queries. Some queries didn't work, but it showed that our data was there. It persisted correctly. So to build the app itself, we use Streamlit and then Langchain, as well as Google Generative AI, in particular the Gemini LLM, and then we hosted it on a Hugging Face space. So here are some example queries which we used. So which shark has the most deals? Get Mark Cuban has the most deals. Which startup received the most support from Lori? We get the best products. So we don't even have to write the investor's name in full. The line chain helper helps generate the natural language into a proper query in our graph database. Let's try which startups received investments from all sharks. Based on the data, no startups received investments from all sharks. Which startups received investments from at least 3 sharks? Here we get IRA, Bidvine, and so forth, startups which have at least 3 sharks. We can try which industry has the most startups. The industry with the most startups is food and beverage, with a total of 305 startups. So our chat interface is working correctly, which we are happy with. It's a good starting point to help in the private equity business um, to analyze investments between venture capitalist investors and respective startups. In our analytics dashboard, we've got Shark Tank, Shark activity, distribution of startups. So here we've got a bar chart showing how much startups received from 240K to $250,000, and then from 250K to 740K, which here represents accounts of 370. Then we've got 31 from 750K to 1.24 million. And here we've got a bar chart of the investors themselves showing how many deals they did. Um, and then And then we've got our graph visualization, which we show here, showing the nodes between the investors, the nodes and the edges, the investors and the startups themselves. So this is just an example of how we can apply a graph solution in the private equity industry to generate insights between investors and startups. So hopefully this can be a starting point for generating insights for investors. This is the end of my submission. I hope it was a worthy one.